Okay, so circles, you guys remember, right? So what are the different parts of a circle? Like, let's say this is a circle. Then, so you have radius versus like, what would be the radius? Tanisha, what is the radius of circle?
A line from the center of the circle to the circumference.
Center to circumference. Circumference is the boundary of the circle. Okay. So OA is the radius. Then Ananya said diameter. What do you mean by diameter, Ananya?
It's double of the radius.
Double of the radius. So can I, if I draw another line like this, can I call OA and this point B as the diameter? Because it's radius plus radius. How exactly? How would you define diameter?
Ma'am, can I?
Yeah, go ahead.
Ma'am, a line passing through, touching the one point of circumference of the circumference passes through the origin and touches the other side of the circumference.
Okay. So it's basically a line segment that whose endpoints lie on the circle, and it should also pass through the center. Okay, so if we call this C, then yes, AC, the whole thing, is the diameter. What is the relation between radius and diameter? If we call radius as R, diameter as D, what is the relation between R and D?
E equals to R.
D upon 2.
D equals
to R.
2R.
Or as somebody said, you can say R equal to D by 2. Okay, diameter is double of the radius. Ho gaya. Sarah has mentioned chord. Now, what do you mean by a chord? How should I draw a chord?
Can I tell?
Let's give it to somebody else. Who else? Abhishek Trivedi. What do you mean by a chord?
Chord means a line joining A and B.
Line joining A and B. Okay, so any 2 points of a circle, that would be a chord. Here. So AB is a chord. So going by the definition, is the diameter also a chord? Yes, no?
Yes, ma'am.
Yes.
That's the longest chord.
Very nice. So diameter is the longest chord. So technically diameter is a chord because endpoints lie on the circle. It's a line joining any 2 points on the circle. Just that it happens to pass through the center. So fir wo diameter ho gaya. So diameter is the longest chord. Okay. So these are like some of the basic parts of a circle. Then you have, okay. So pizza, like consider a circular pizza. You slice pizza, like you basically draw diameters and then you slice it. So what do you call each slice of a pizza? What is the shape of each slice of a pizza? So if I were to highlight this, what is this shape called?
Is it a sector? I can't remember from last year.
Absolutely, Raghav, you're right. So if you think of a pizza slice, so it's a part of a circle that is enclosed by 2 radii with, and like, such that they have some angle between them. And the other side is part of a circle. So this part, the blue color part, is called a sector. Okay. So sector is defined by, like, of course, circle ka part hai, to radius se define hoga. And also, what is the angle at the center? So it is enclosed by 2 radii, right? So the angle between those radii, call it theta. Greek letter theta. So this particular shape is called a sector. So if you think of a pizza slice, it's a sector. Okay. So depending on which angle you're considering. So abhi, if I have a circle and I take two random radii, so this is also one angle and this is also another angle, right? So whichever sector you get from the smaller angle, that's called minor sector. And whichever sector you get from the bigger angle, that's called major sector. Again, it's directly related to the words. Smaller angle is minor, greater angle, bigger area. So that's a major sector. Okay. Okay, now consider a chord. If I draw any random chord, it divides the circle into two parts. Like, let's say I draw this random chord. Okay, so this chord, let's call this point D. CD divides the circle into two parts. There is this part, and then there's the bigger part over there. So what are these parts called?
Ma'am, minor and major segments.
Absolutely. Rishita and Sarah also got it. Yeah. So the red color shaded area, the part between circle and a chord, is called a segment. And again, just like a sector, if it's a smaller area, that's a minor segment. If it's a greater area, that's a major segment. Yeah, Raghav, what's up?
Ma'am, if we consider AC as the chord, then with respect to AC, which is a minor and major, because both are equal, so both will be
Both are
minor or
equal.
both?
Yeah, they're basically the same thing. They're congruent to each other, right? So then you don't define minor or major. Whatever you do, it's the same thing. Like whatever area you find out, anything related to that, it's going to be the same. So it's not defined for this thing. But if you consider the segment formed by a diameter, that has a special name. What is that called?
Ma'am, can you repeat your question?
Yeah, we'll discuss that in a bit. Okay, that's a good point. Even for sectors, you have like certain special names to it. Okay, so we have minor and major segment. Smaller area is minor, greater area is major. Another important this thing that I forgot to discuss earlier was, what do you call a part of a circle? Like if you consider the whole circle, uska boundary is called the circumference, right? But instead of the complete circle, suppose I take only a little bit of it. So what is that part called?
Arc?
Yes. So part of a circle is called arc. That is absolutely right. Ananya, Deshna, Sara, Rishita, all of you have answered. Good. So these are like basic parts of a circle. Should be familiar with what is a chord, what is radius, diameter. Then the things that we'll be dealing with in this chapter this year. So you need to know what is an arc. So it's like just part of the boundary of a circle. That's an arc. Then you need to know what is segment, like major and minor segments. Chord divides it into segments. So if you think it's something like this, watermelon, for example, that's a segment. Pizza slice, if it's like enclosed between two radius, this is a sector. Something like this is a sector. Okay, so these are like the basic parts. This chapter is all going to deal with perimeter and area related to these parts of the circle, either the entire circle or of a sector or segment. Okay, so this chapter, it's part of the same unit as your surface area and volume. So you need to learn all the formulas related. So that's like a small part of it. But 50% of it, if you want to be able to answer questions from this chapter, it is majorly going to be understanding the question. So you need to know whether they're asking for area of a sector, is it major or minor sector, or perimeter of a sector, or could it be a segment? So that interpretation you would need practice in. Okay, so 25% of it is like knowing the formula that you need to remember, but major part is being able to apply that formula for that question. So that's what you got to focus on. Okay, all right. So there's some special cases to sectors and segments. Okay, so sector, I said, was defined by theta, which is the angle between both the radius. So one special case of this is when the angle between the radius is 90 degrees. Okay, so when theta of a sector is 90 degrees. Can you guess what this kind of a sector is called? You're very familiar with that word. Maybe you don't know it in this context.
Quarter.
Can you repeat that, Ritvik?
Quarter.
Quarter, yeah, it's quarter of a circle, but iska special name is quadrant. Simple. So quadrilateral is four-sided, right? So quad relates to anything that is four. Now, if you consider 90%, like 90 degrees angle, basically four quadrants make a complete circle. So you can relate it that way. Rishita is asking about pi. Pi is a constant. It's a number. Like, yes, it like pi is used in the formulas of this thing, but it's a constant. Its value is 3.1415, like it goes on. Yeah. But so this kind of a shape, whenever theta is 90 degrees, that's called a quadrant. So if you come across a question saying, talking about a quadrant, then you need to automatically figure out that, oh, theta is 90 degrees. It's 1/4 of a circle. That way. Yeah. Next, if theta is 180 degrees, so radius basically becomes straight line, the two radii together. So this shape will be called in this case theta equal to 180 degrees. Yes, Vasudha got it. Who else? Ryan, what do you think? What is the name of this shape?
Ma'am, can you repeat the question?
हाँ, तो यहाँ पे एक फिगर ड्रॉ किया ना, तो सेक्टर में दो रेडियस है ना, तो उन दोनों रेडियस के बीच में if the angle is 180 degrees, then it forms a shape like this. So what is this shape called?
Semicircle.
Semicircle is absolutely right. So Ritvik, Rishita, Bhavika, Tanisha, a lot of you got it. Nice. Semicircle. Okay. Semicircle, again, is a segment formed by diameter. Like segments are formed by chords, right? So if that chord happens to be a diameter, you end up with a semicircle. That's another thing you can note down. Yeah. What else do you have related to this? Yeah. Are you guys noting this down? If you want, you can note it down, like basic parts of a circle. If you're ready, we can go to the next part. Like we'll discuss all the formula. Okay. This formula also is like very, very easy. It's very logical. You can figure out why those are the formula. It's not out of the blue. Okay. So let me know when you guys are ready to discuss. In case you're noting it down, if you need me to go to the previous slide, also let me know. And yeah, finish this part.
Ma'am, can you go to the previous slide once?
Yeah. Will do. Okay, let me know when you're done, huh? Then we'll go to the next part. You can put it on chat or you can like react with whatever it is. Okay. Rishita is done, Jasmine is done, Vasudha is done. Okay, Abhishek is ready. Then Deshna and Ananya are also done. Okay. Neil is ready. Yeah. So note down and yeah, put your update here. I'll be back again. Bhavika is also ready. Jaden and Tanisha are also ready. Raghav's also done noting. So Amey Sonkhaskar, Ryan Gandhi, Ritvik. Ritvik's also done.
Yes, ma'am.
Huh. No, just calling out those I'm waiting for. Okay. So Amey Sonkhaskar. Okay, Abir has just joined in. What happened, Abir?
Ma'am, actually, I forgot about the class.
Oh my god, इतना बड़ा लंबा break मिल गया that you forgot. Okay. Ryan's also done. Okay. So Abhi, the first half an hour, like catch the recording. We were discussing basic, like what are the different parts of a circle and all that stuff.
Yes, ma'am.
All right. Amey Sonkaskar, what happened? What's up with you? Where are you? Done. Okay. Okay. So now coming to the formulas. Now this is the bulk of the chapter. So let's say you have a circle, jiska radius is r. Let's just draw a circle. This is the center O and radius is r, diameter is d. So what is the circumference of a circle? Circumference will be equal to
2 pi r.
2 pi r is absolutely right. So these things definitely noted down, whether you noted down the previous ones or not. These all are important. Okay. Next formula would be area of a circle.
Pi r square.
Pi r square.
Pi r square. So these two you're familiar with. Now coming to the bulk of it. Okay, so if we consider a sector, then theta b aa jayega, right? So even if we are to consider an arc, let's call this AB, and then iske beech mein chord also will be AB. So first, let's look at what is length of arc AB. How would you find that out? Okay, so the way you find out is very, very easy. So if theta is equal to, okay, what is the total angle in a circle? Like agar yahan se start karke, if you come back to the same point,
360 degrees.
pura is 360 degrees, right? So if you travel 360 degrees, yahan se start karke pura 360 degrees if you travel, what length would you have traveled?
2 pi r.
So distance length or length that you have traveled from here all the way to here would be 2 pi r because you're doing one whole circle. Iska radius is r. Now, instead of going the pura 360 degrees, you just went from A to B. You just went theta degrees ka angle. So for length kitna, like how much would you have traveled? How much is this part of it? Yahan se yahan tak. So it's like a unitary method. So agar if you go pura 360 degrees, you travel 2 pi r, but instead of that, you traveled only part of it. Not the whole 360, you traveled only up to theta. So how much would that be? Use unitary method and work it out, you'll
Pi
get.
r upon 360.
Can you repeat that?
2 pi r upon 360.
2 pi r upon 360, that you'll get for 1 degree. So 360 degrees pura ke liye 2 pi r. For each degree, you'll get 2 pi r upon 360. But
So 2 pi r upon 360 into whatever the angle of theta is.
correct. So length of arc AB is equal to, usko thoda sa I'll rearrange it. So that will be equal to theta upon 360 into 2 pi r. Okay. So if theta was equal to 360, if the angle was 360, so 360 cut okay, you'll get complete 2 pi r. So if theta is 180, like if you are considering semicircle, 180 upon 360 is 1 by 2. So you get half of the circle, semicircle. If theta was, any random angle theta, if it was 30 degrees, 60 degrees, then it will be theta upon 360 into 2 pi r. So that is the length of arc AB. Okay. Similarly, can you figure out what is the area of sector? So again, same sector we are considering between OA and B. So ये अगर ये वाला sector consider कर रहे हैं, तो what would be the area of this sector? Can you figure out the formula?
Theta upon 360 into pi r square.
Absolutely. That's what is going to be the area. So this is going to be equal to theta upon 360 into pi r square. Same logic. So for complete 360 degrees, full circle ka area is pi r square, but you're not considering the full 360 degrees. You're considering only part of it, which is jo bhi angle hai theta. So again, theta upon 360 into pi r square. So this is the area of a sector. So yahan tak it's pretty easy. Now, if we have to find area of segment, okay, how would you find it? So segment matlab I'm shading here. So if you want to find the area of the shaded area alone, how would you find it? To find area of the shaded area, like to find the area of the shaded portion, what are the shapes? Jiska formula you already know in this scenario. Yeah, Jasmine?
Ma'am, could we subtract the area of the sector by the area of the triangle?
Absolutely. That's exactly what you do. Abir also answered triangle. So we know the area of the sector. Idhar hi formula hai. So area of sector will give you the whole part ka area. Usme se we don't want the white region, this ye triangle wala region. So area of segment will basically be equal to area of sector minus area of the triangle. Now there's no exact formula for this because yeah, area of sector, so you'll use this formula only. So you can use that. So that's like theta by 360 into pi r square minus here I'm just writing area of triangle because this depends on the situation. Like in some cases, area of triangle, you can use half into base into height. Uske liye you need to know height ka formula. Koi bhi base ya height ka formula. If you're given length of the chord and if you're given the height, that is one way to find out. Another way you can find out is you can use half BH. If theta was 90 degrees, then base and height is going to be the radius itself. If theta was 60 degrees, then this becomes an equilateral triangle. Do you guys remember the formula for area of equilateral triangle? Yes.
Ma'am, root 3 a square upon 4.
Absolutely. Agar equilateral triangle hai, so you can use root 3 by 4a square. Half BH is another formula you can use. What is another way you can find area of a triangle?
Ma'am, from sides.
Yeah, what formula will you use sides say? Like if you're given all three, like radius, so you'll know because sector area ke liye you need a radius. And if you're given length of the chord, then that means you know three sides of the triangle. So using the sides of a triangle, how will you find the area? You guys had learned it in 9th standard. Do you remember? Deshna, do you remember the formula if you're given three sides of the triangle? Yeah, Rishita got it.
And we need semi-perimeter, na?
Yes. What is that formula called? Like either
Can I
you,
try?
yeah,
Ma'am,
Rishita.
root S,
Uh,
root S plus S minus A
S plus नहीं,
in-
S into है,
into
S minus A,
S minus A into S minus B into S minus C.
correct. Nice, well done. अभी भाविका को भी याद आ गया. So this formula is called Heron's formula. Now do you remember? पूरा 9th में एक chapter पूरा था ना, called Heron's formula. Okay. So this you will need to use your judgment depending on the situation, depending on what all values you're given, what you'll be able to use. So equilateral triangle chahiye, so you have your formula. Right angle triangle chahiye, agar if it's a right angle triangle, or if you're given like this particular height, then you can use half BH. And if you know all three sides, then you can use Heron's formula. Yeah, so that's basically it. Cool. So note down all of these formulae, and once you're done with this, then we'll go. Then we can start with the questions. So a lot of questions, like 50% of the questions, you guys will be able to do it because you've done it in like 8th grade and maybe 9th grade also, like area of a ring and all of that stuff. Sector and segment are only the new parts of this chapter, so that you need to focus on a little bit. Okay, so let me know when you're ready to do the questions. Tanisha is ready.